I welcome you all to K-Tech High School and Junior College. Hello children, as you all know we have started Composition of Matter lesson number 6, and in today's session we are going to learn about solution, suspension and colloid. So children, let's begin. To begin with, the first one we shall see solution. Let's see what is a solution. Solution: a homogeneous mixture of two or more substances is called solution. It means when two or more substances are mixed together, they form another substance in a single phase. So it is called as a solution. Understood? Now children, here we have a salt, we have water. Now here salt is available in less proportion. So the substance or the component which is available in the less proportion, it is known as the solute. Okay, and whereas the substance which is present in a larger proportion, so it is known as a solvent. Okay, and when we mixed these two things, that is the solute and the solvent together, the final result which we get is the solution. Are you getting me children? See here, we have mixed salt with water. Salt dissolves in water, then we get a salt solution. Now, apart from this, the solution can also be of the types liquid in liquid. For example, vinegar, dilute sulfuric acid. The next we have, let's see, it can also be available in gas in liquid. For example, chlorinated water, hydrochloric acid, that is HCl. Gas in gas, for example, air. And solid in solids, for example, alloys like brass, steel, stainless steel, etc. If the solvent is a transparent liquid, the solution is also transparent and it passes through a filter paper. Now let's see what is a suspension. A heterogeneous mixture of a liquid and a solid is called a suspension, which means when one solid substance is dissolved or mixed with the liquid, forming two phases or two or more phases. It is called as suspension. Are you getting me children? What is a suspension? Now here we have a mixture of sawdust and water. We can see clearly that there are two phases. Hence, it is a heterogeneous mixture. Now, the diameter of the solid particles in a suspension is larger than 10 raised to minus 4 meter. Therefore, light cannot transmit through it. So these solid particles remain on an ordinary filter paper as residue, and there are liquids and solid components of a suspension gets separated by filtration. Yes, children? Now let's see what is a colloid. A colloid is a mixture where one substance of microscopically insoluble or soluble particles is suspended into another substance. Here it means when very small substances are mixed with another substances or liquid. It is called a colloid. Are you understanding, children? Let's see an example. Here we have a mixture of water and milk. The diameter of these particles is around 10 raised to minus 5 meter. However, the pores of the filter paper are larger than colloid. Hence, the mixture cannot be separated. Are you getting me, children, what I am trying to explain you? Good. Let's move ahead. Milk itself is a colloid. There are some more types of colloids. For example, solid in gas, that is smoke, liquid in gas, that is fog. Here we can see that there are 3 glasses which are kept, which includes a solution, a colloid and suspension. We have a light source. When light is passed, we can see the observation shown there. Light beam is not visible in solution. It is visible in colloid and also visible in suspension, as you can see on your screen. The examples of solution are water, and the example of colloid is milk, and of suspension is flour and water. Understood, children? Now let us study molecular formula and valency by cross multiplication method. So children, let's begin. molecular formula and valency. There is a definite proportion of the constituent elements in a compound. Means in a compound the constituent elements are in a definite proportion. Certain number of the atoms of the constituent elements are joined to each other in a molecule of a compound. In a certain atoms the constituent elements are joined by a molecule of a compound. Molecular formula indicates the number of atoms of each of the constituent elements present in one molecule of a compound. Means when we look at the molecular formula, we can say that how many atoms are present in an element which is there in a molecule of a compound. A molecular formula includes the information regarding the symbols of all the constituent elements and their respective numbers of subscript. Subscript means the number which is being written by along the molecular formula. Now see here, we have this table on page number 45 of our textbook. Now in this textbook, the table which is being shown, we have names of compound, their molecular formula, constituent elements and number of atoms of constituent elements. Now the first one, the molecular formula is H2O. The name of the compound is water. So here the 2 is written after H. So 2 is the subscript written. Understood? The same we can see in the third one, CH4, that is methane, where 4 is the subscript. Are you getting me? The first one they have solved us for, where the constituent element is H and O and number of atoms of constituent elements are 2 and 1. The second, hydrogen chloride, where the molecular formula is HCl. Constituent elements are H and Cl, and the number of atoms of constituent elements of H is 1 and Cl is 1. The next we have methane. Molecular formula is CH4. So the constituents elements will be, can you tell me children? Yes, it is C and H. And what would be the number of atoms of constituent elements? For C it is 1 and for H it will be 4. Why 4? Look at the formula. It is CH4. Understood? The next we have magnesium chloride, MgCl2. The constituent elements will be Mg and Cl and number of atoms of constituent elements will be 1 and 2. The ability of joining to another atom with a chemical bond is a chemical property of each atom. This ability is indicated by a number, and this number is called the valency of that atom. Understanding, children? Now we have another table which is being shown on page number 46 of your textbook. Here they have a molecular formula of a compound, constituent elements, valency of H, number of bonds formed by X with H with valency X. Now in this table, the first two have been solved for us. Let's begin with the third one, H2S. Now here the valency of H, it is constant, that is 1. Okay, and in H2S the constituent elements are H and S. So the valency of H is written 1. Number of bonds formed by X with H is 2, because we are having H2S. So we'll write 2. And the valency will be what? The valency will also be 2. Got it? The next is NH3. So the constituent elements will be H and N. Valency of H is 1 as it is constant, and number of bonds formed by X with H is 3. So the valency will also be, can you tell me? It will be 3. Correct. Next we have HBr. Constituent of elements will be H and Br, and number of bonds formed by X with H is 1 with the valency 1. Valency will also be equal to 1. Isn't it? Now the rest 3 children, you have to do it for me. Please do try doing it. Valencies of the constituent elements can be deduced from the known molecular formula of a compound. We can find out by cross multiplication method. Now let's see what is cross multiplication method. Cross multiplication method for writing the molecular formula of a simple compound. So the first step number 1, we need to write the symbols of constituent elements. So here we are writing C and O. So the next step 2 is to write the valency below the respective elements. C we are writing 4, O 2. Now after writing the valency, we need to cross multiply to obtain the number of atoms of the constituent elements in the molecule of the compound. So we have put an arrow sign for cross multiplication. So what we will get after this cross multiplication? See here, step number 4. Then we write the formula of the compound obtained by cross multiplication. So we got the formula as C2O4. Step number 5 will be to write the final molecular formula of the compound. The number of constituent atoms in the final molecular formula should be the smallest possible whole number. So, for getting this, we divide the formula obtained by a suitable number. So, formula obtained by cross multiplication is what? C2O4. So, when after dividing it by 2, the final molecular formula which we get is CO2. Got it? So children, we have this table on page number 46 where we have the elements, valency, molecular formula of the corresponding compound. So we need to find out the molecular formula by cross multiplication. Now look here, C with 1 and H with 4. If we cross multiply, the formula which we get is C1H4. That is CH4. Is it easy, children? Yes. The next one, let's see. NH, where the valency of N is 3 and H is 1. So here also we will do a cross multiplication. So can you guess the formula? It is NH3. N1 and H3. If it is 1, we directly write N. No need to mention the subscript 1. The third is Fe and S. If we cross multiply these two, we get Fe2 and S2. So what we'll do here? We will divide it by 2 to get the smallest possible whole number. So we will get here, after dividing it by 2, FeS. Understood? Now the last one, C with the valency 4 and O with the valency 2. So after the cross multiplication, we get the formula as C2O4. So what we'll do here, children? Again, we will divide it by 2 to get the smallest possible whole number. So after dividing this by 2, we get CO2. Isn't it easy to understand? Very good. Now, children, let's take a quick look at the summary of today's session. Solution. A homogeneous mixture of two or more substances is called a solution. Suspension. A heterogeneous mixture of a liquid and a solid is called a suspension. Colloid. A colloid is a mixture when one substance of microscopically insoluble or soluble particle is suspended into another substance. Let's see the notes for today's session. First, new words followed by glossary. Then question number 1, choose the correct option and fill in the blanks. Give 2 examples of each, followed by the give reasons. Write the scientific reason for the given statements. Then you have to write the chemical composition of matter. The table is shown here. Please write it accordingly correctly. Then deduce the molecular formulae of the compound obtained from the following pairs of elements by cross multiplication method. I hope children today's session was interesting and easy for you to understand. So, we will continue in our next session with a new topic. Till then, children, take care and thank you.